All right, let's take a look at systems of equations application. So basically we're going to be constructing or writing systems of equations of our own from word problems and solving them. So our first problem here says the cost of 3 boxes of envelopes and 4 boxes of notebook paper is $13.25. So first we notice that we're dealing with 2 separate items, and so we're going to use standard form to write our system of equations because we have 2 separate items. There's no rate of change, so there's no slope. All right. Next, we have 2 boxes of envelopes and 6 boxes of notebook paper that cost $17. So first, let's define our variables. I'm going to let X equal my envelopes. And I'm going to let Y equal my paper. I could use E and P for envelopes and paper, but I'm just sticking with X and Y. But you can pick any variables you like, which is why we define the variables. And next, let's write this system. All right, so 3 boxes of envelopes, so that would be 3x, and 4 boxes of notebook paper plus 4y is equal to, or is, $13.25. So that would be equal to 13.25. All right, so next, 2 boxes of envelopes, so that would be 2x plus 6 boxes of notebook paper. 6y is equal to the cost of $17. So we've written our system. All right, let's solve it. So now looking at it, the best way I think to solve this would be using elimination. So basically we're going to multiply both equations by a number to get opposite coefficients. All right, so I'm going to eliminate my y values. So the greatest common factor, or the greatest common multiple between the 4y and the 6y would be 12. So I'm going to multiply my top equation by 3, because 3 times 4 will give me 12. And I'm going to multiply my bottom equation by -2, because -2 times 6 will give me the -12. All right, so let's write our new equation here. 9x plus 12y is equal to 39.75. Multiplying -2 by everything. In that second equation, that's going to be -4x minus 12y is equal to -34. Let's solve it. Of course, using elimination, my 12y will cancel out. And you could have canceled out the x's if you wanted to. If you still need a little assistance with solving using elimination, please see my video, solving systems of equations using elimination, and I will link it at the end of this video. All right, so using elimination, 9x minus 4x will give me 5x. 39.75 minus 34 will give me 5.75. Now I'm just left with the one-step equation because my 12y canceled out. Dividing by 5 because I want to isolate my variable. And I get 5.75 divided by 5 is 1.15. So since we're talking about dollars here, because how much is the cost? So X is envelopes, so that would be $1.15 per envelope. That's my messed up dollar sign there, but it's $1.15. So now we want to find our paper. So since X is 115, I'm going to just plug it back into one of my equations here. All right, so I'm going to plug it actually into this second one right here because I have the smallest numbers. All right, so 2, since X is 1.15 or $1.15, that'll be 1.15 plus 6y is equal to 17. We're just simplifying from that point. 2 times 115 is 2.30 plus 6y equals 17. Left with the two-step equation, subtracting 2.30 6y is equal to 14.70 divided by 6. Y is equal to 2.45. So since we're talking about money, that is going to be $2.45 for the paper. Alright, and so we have set up a system. This was my original system right here. So if you were just asked to write a system of equations, this would be your answer. But if you're asked to solve it, you can use elimination, substitution, or graphing. In this case, I chose to use elimination. Alright, so let's take a look at this example here. It says a garden supply store sells two types of lawnmowers. The smaller mower costs $249.99 and the larger mower costs $329.99. If 30 total mowers were sold and the total sales for the year was $8,379.70, how many of each type were sold? Alright, so we're not given a specific number of how many of mowers were sold for each one. We have to find that. So we first want to define a variable. So let x equals small mowers and let y equals the large mower. So we want to write a system of equations. So the first thing we want to do, since we don't know how many of each, we just say x plus y equals the total amount, which is 30. So we know that 30 mowers were sold, but we don't know how many of each. That's what we're looking for. So we just use our variables that we define, x plus y. If you want to use small and large, S and L, that's fine, but it's just x plus y equals 30. So we just use our variables that we defined. And then our other equation would be the price. So 249.99 x, so that is the price of our small mower, plus 329.99 y, that is the price of our large mower, and the total was $8,379.70. So we have our money in our second equation, and we have our mowers, or how many mowers in that first equation. And again, we have to figure out how many were sold of each type. So we basically just want to solve this system. Alright, so first thing we do, we want to solve using substitution because we have all these decimals, right? And so we don't want to multiply another equation by decimals to give us even more decimals. So if we want to solve using substitution, of course we solve for one of the variables first. And so we've solved this here for x. The y becomes negative because I simply subtract y from both sides. And what would I do with this negative y plus 30? Of course, I'm going to substitute it back in. And so since that equals x, instead of putting x here, I replace that negative y plus 30 with x. So I substitute it. Then simplifying distributive property. So I'm left with this equation here. I'm not going to read it out, but that's what I'm left with. So you may want to pause the video if you're writing this down. Alright, and so from that, I'm combining my like terms. And so my like terms, right here, negative 249.99y and 329.99y. When I combine those, I get 80y. Alright, and then that's going to be plus 7499.70 is equal to 8379.70. Subtracting. So I'm just, excuse my handwriting here, solving this two-step equation. It just has large decimals. I'm left with 80y is equal to, it should be a minus 880. Dividing by 80, I don't have room for that, but that's a one-step equation. If I divide both sides by 80, I'm left with y is equal to 11. All right, so how do I find x? So using substitution, since y equals 11, I'm going to use this equation here. So x is equal to, instead of putting a negative y equals 11, right? So that would be negative 11 plus 30. So x would be 19. So looking at our variables, we have 19 small mores because that is what my x represented, and 11 large mores because that is what my y value represented. All right, so we've solved this word problem using systems of equations and solving by substitution. All right, I would like for you to try this problem on your own. So go ahead and pause the video and try this one on your own. All right, and so the system that you should have written was 4x plus 5y is equal to 6.71. For 4 pens and 5 pencils is equal to 6.71. And then 5x plus 3y is equal to 7.12. And of course, you could have used different variables as long as you define the variables. When you solve the equation, you're able to define or show what's what. So in this case, pens and pencils, it should have been $1.19 for the pens and 39 cents for the pencils. So I hope you got it correct. If not, I suggest you pause the video, look over it again to make sure that you understand how to write systems of equations from word problems. Alright, so we've reached the end of our lesson and our video. I want to thank you for learning with me. Some related videos are solving systems of equations by graphing and solving systems of linear inequalities. And if you haven't already, please like, comment, share, and subscribe. And again, I want to thank you for learning with me.